So good afternoon everybody, myself Acharya Vishvendragat. I was just discussing about analysis of momentum. So let's discuss the graph of P versus V. So we know that the graph is a straight line with tan theta is equals to m. This we have discussed in the previous video. So we can say that tan theta is equals to m. So if we have three different graphs, 1, 2 and 3. So from the graph we can see that theta 3 is greater than theta 2 is greater than theta 1. So we can say that tan theta 3 is greater than tan theta 2 is greater than tan theta 1. So we can say that m3 is greater than m2 is greater than m1. So we can say that larger the angle, the larger the slope angle, larger is going to be the mass of that particular body which is under consideration, for which we have drawn the graph. So this is the inference that we can draw from the analysis of the graph. Now let's expand our thinking process to another dimension. Let's try to relate kinetic energy and momentum. So we know that kinetic energy of a body is half mv square. So what we do is we just multiply and divide by m. So here we have m square v square by 2m. Then we take whole square as common, so it reduces to mv whole square by 2m. mv here is p, so we have the expression k is equals to p square by 2m, where k is the kinetic energy and p is the magnitude of linear momentum and m is the mass. So this is the relation between the kinetic energy, the momentum and the mass of the body. So we have come to another conclusion relating momentum and the kinetic energy. So since one inference can be drawn that if we double the momentum without changing the mass, so how much kinetic energy will be increased? So obviously if there is a p square term involved, so if we double the p, then it will be 2 square, that is 4 times. So it will be 4 times or 400 times of the initial, 400% of the initial value. So there is an increase of 300% in the kinetic energy that we can draw from this analysis. Let's see some variations in the graphical perspectives. So the first thing is graph of k versus p. So we know that k is proportional to p square, so the graph is gonna be a parabola. We assume that mass is constant over here, so that will be a parabolic graph. If we draw a graph between k and p square, we assume that p square is x over here. Here also we have assumed that mass is constant. So we can say that tan theta will be k by p square, so that is 1 by 2m. So we can say that tan theta is proportional to 1 by m. So for the graphs, as the graphs are concerned, we can say that if slope angle is theta, then tan theta is